Okay, welcome back. We are continuing with Unit 7, and the design element that we're going to be talking about in Unit 7 is basically the pictorial illusion of space, and that is going to lead to a pretty intensive discussion about, about perspective systems and the different parts of a perspective system and the different types. And then we're going to look at some artwork that is either using perspective or based off of perspective. But before we get there, we have to kind of talk about how the illusion of space, of dimension in a picture plane, because after all, a picture is a flat thing, right? Any painting or drawing has no real depth. It's only a completely flat thing. The, you know, all of the depth that we read into the picture is created purely through illusion, and that there are some basic means by which people do that in artwork. So we're going to talk about that before we talk about perspective systems. So we're covering it for this unit in part because this unit we're talking about printmaking, and this is one of those prints by Dürer that I noticed as I was putting together the lectures, and it is a classic Dürer print about two men working a mechanical perspective system, trying to figure out the exact mathematical means of foreshortening a drawing of a lute, which is pretty amazing and pretty interesting. And but the other reason is because we covered perspective a little bit in the Renaissance, and we're now moving past that. But I kind of feel like, well, we ought to cover it as much as we can. Now is as good as any time to do it. So to begin with, let's talk about the illusion of space, how to make space if we don't have any kind of perspective system. There are some basic ways that someone can create the illusion of space in any drawing. And the most obvious one is overlap. If you draw three circles, if you just say that you just put a little bit of the contour edge of one circle in front of the other, creates the illusion that one's in front, and that creates the illusion of space. The next most obvious one would be scale change. That, if you had a drawing of 5 trees and you had one tree really, really big, and then another set of 3 that were a little bit smaller, and then one that was much smaller, it would probably, as long as your position of where you place those trees was pretty good, it would create the illusion of space. And that leads to the next most important one, which is placement. Sometimes this is called vertical positioning, because you could notice this little drawing here, these kind of egg-shaped circle kind of stones, they're all pretty much the exact same size and drawn pretty much the exact same way. The only difference between them is how high up on the page they are, right? Now there's a little bit of an implied diagonal between them, but even if they weren't, even if we brought that one over there, it would still look like that one was further away than this one. The illusion here is the idea that these are sitting on a plane, on some sort of surface, and that therefore, and if our viewpoint is above that surface, then we know automatically that things are going to go higher up that surface the further away they go. So vertical positioning, otherwise known as placement, but I prefer vertical positioning because it's more specific. Modeling and shading can also contribute to the illusion of space, and but probably more importantly would be, apologize for the dogs, I need you to actually, would be changes of value that create a sense of depth. So oftentimes, and this is kind of a complicated issue because it has to do with the issue of atmospheric perspective. Value can create depth, and usually, like let's say you're doing a drawing on a white piece of paper, that means that darker values are going to appear closer to us and lighter values are going to appear further away. But if you reverse that and you did a drawing on a dark gray piece of paper and you used lots of white chalk as well as black chalk, then the lighter values would tend to be the things that come more forward. But more importantly, value contrast tends to come forward. If you have a thing that has lots of contrast, lots of light and lots of dark, that's going to tend to come more forward than something that has more restrained contrast. Okay, so clear on that? So here's an example of a piece we have seen a number of times already that is creating lots of space and doing it pretty much without any kind of reference to any perspective system. Although, to be completely honest, that drawing of that tub is really quite solid. But it's not really using any kind of vanishing point or perspective lines. But the way it's creating space is almost entirely just through layering, through overlap, and through like the idea of this plane here being in front of the tub, her being in front of the tub, these things being on top of that shelf plane. All of that just creates all of this depth in the picture. And so, you know, there's kind of proof positive that you don't need a perspective system to have very believable and very accurate illusions of depth. Now let's talk about probably the most important perspective system, but that also is probably the most maligned and overlooked perspective system, which is isometric perspective. For the most of the history of art, perspective system was isometric. People have, for many centuries and many different cultures, drawn things out in isometric systems. Isometric systems are where you draw the objects pretty much the way they are rather than the way they appear. To put it another way, like, so if you had a box and it was 4 inches and all the way around, it was a square cubic box, then you would draw it where all heights from every corner was 4 inches, right? You wouldn't have it diminish or get smaller as it went away. The way it appears, you would draw it the way it is. So in isometric perspectives, they have a sense of being a little bit unreal because they don't do something that we know in the visual world that things do, right? That like this doesn't stay parallel to that. In the real world, those two things, those two angles are not the same and they converge towards each other. Or the same with this mat right here. The way that line and that line are completely parallel to each other is true to the mat, but it's untrue to the way we see things like that mat. Okay, here's some more examples. So one of the reasons why isometric perspective is so important is because it's really useful for all kinds of renderings, architectural renderings, or industrial design renderings, or theater renderings. If you're trying to design a prop or a set for a theater production, you would most likely draw it in isometric perspective. So once again, notice that height there is the exact same length as that height there. If we were drawing it in linear perspective, right there, if we're drawing it in linear perspective, we would make those two heights different from each other. Also, many of the great classic video games were designed in isometric perspective because it allows really good kind of like above view gameplay, right? So, 1-point perspective. So we have evidence that there were systems like 1-point and 2-point perspective that existed before the Renaissance. It appears from, like some of what we see from Pompeii, that artists were aware of perspective systems, but we still don't know exactly in the classical world and in the Roman world what they actually knew about how perspective worked. But perspective was invented and to a certain degree reinvented in the early Renaissance, primarily by Brunelleschi, who was an architect. He invented it for the purposes of making sure that his renderings were accurate. Like he would be going out to draw some Roman ruins, and he's drawing a set of columns, and he wants to be able to, in his drawing, know for certain that the distance between, that's my 1-minute warning, so I'll probably wrap up. Next, after 1-point perspective, we're going to be talking about 2-point perspective systems and beyond. All right, speak to you.